Hi, I'm Sethu Veeraraghvan, and my final project is based on embedding dialect and vector database, NLP basics. Natural language processing is all about processing words and sentences to extract meaningful information. Example, classification. Pre-process the words and sentences. Stop words, morphology, modification of words, stemmer and lemmatization. Example, knives are converted to knife. And named entity recognition. Add new words to treat as an entity. Words and sentences are not numbers. We need to represent words in numbers so that we can do computations. The techniques to translate the words and sentences to numbers are listed below. The counter vector counts the number of occurrences in a given document. The TF-IDF, the term frequency, and the inverse document frequency formula, and one-hot encodings. And the pros and cons are the cons are the curse of dimensionality. Matrix is sparse and higher dimensional. The number of features is higher than the number of data points hard-coded. No new words can be added. The pros are provides a foundation for understanding on how to convert words to numbers, can work with any given dimension, easy to understand, and continuous back of words and n-grams over the methods to predict the words. Embeddings represent a word in continuous numbers in n-dimensional space. For language translation and text generation, need to understand the relationship in words and context. Example, that bank sits on the river bank. Example 2, I read a book yesterday. It describes why the sky is blue. See the following word equation. King minus man plus woman equal to queen. And the below chart satisfies this word equation. And how to achieve? There comes the transformer. Resulting vector is called a context vector. And here is the transformer architecture, and the equation is as shown below. And the transformer model. The transformer model consists of an encoder and a decoder block. In encoder, input embeddings are added to positional encoding using some sinusoidal curve to retain the position of the words in a sentence. The NX block consists of two components, the self-attention and a feed-forward network. Using attention weights and input embeddings, they are converted to query key and value. The multi-head attention means that the vectors can be split and fed into multiple self-attention components. Hence, it is referred to as multi-head attention. This helps with parallel processing and thereby consumes less time. Obtains the attention vector as shown in the equation, passing through the normalization and residual connection, which then forwarded to the feed-forward network. In decoder block, the output embeddings are added to the positional encoding using sinusoidal curve to retain the position of the words in sentence. Using attention weights and output embeddings, they are converted to query key value. In, in a masked multi-head attention decoder, the previous words and current words are needed, not the future words. Hence, the future words are masked. The query part is forwarded to multi-head attention. Similar to the encoder, it takes the key value and query as input, obtains the attention vector, passing through the normalization and the residual connection, which then forwarded to the feed-forward network, pass through a linear layer to softmax to get the output probabilities. Cosine similarity. Based on the context statement below, the word apple would have two different vectors. Apple, Samsung, and Nokia products are reliable. Here the apple represents the entity. Apple, oranges, and grapes are good for health. Here the apple represents the fruit. And using GenSim word to vec model, loaded Kaggle hotel reviews dataset, compare the cosine similarity using GenSim model and through manual computation, and values are same as shown below. And word to vector is a 100 dimensional vector. Displayed the vector for the word pleasant as shown here. And took the vectors generated by the word-to-vec model using the words as labels, plotted the Disney plot as shown below, which represents the 100-dimensional vector in two-dimensional space using principal component analysis. And you may see that the cluster of words in the as shown in the plot. And using word-to-vec Google News 300 model, loaded again the Kaggle hotel review dataset, this model produces a 300-dimensional vector, may obtain embeddings for text and images too. And king minus man plus woman equal to queen. Based on that formula, the positives are king and women, and negate the man, and you can see that the queen tops the list, but it says 0.49. So. And I'm using the translate module for translations. And Multiple Python modules facilitate translation and are built by different authors and organizations. Listed the following languages for translation: Spanish, Tamil, and Hindi. Using Gradio for the user interface. Shown below is translation from English to Tamil. Here the statement is Tamil is oldest historical language in the world. Tamil உலகின் மிக பழமையான வரலாற்று மொழியாகும். And this is the original Tamil language where I come from. Getting into the vector database. Vector database store embeddings. Organizations have their proprietary knowledge base. A vector database is used to build internal knowledge base to query the embeddings and get the results. I'm using ChromaDB here, and ChromaDB uses all mini model have for its embedding a SQLite as its internal database. Stores a vector of size 384 dimension, and I'm loading for 3 sentences in ChromaDB as shown here. And querying the vector DB as a review document about Hilton, note that the distance is 0.0, which is exact match for the query that I'm passing in, and the results are shown. And concatenated the review text and city, loaded the concatenated data into ChromaDB, obtained the embeddings using OpenAI embeddings from OpenAI. By default, the OpenAI embedding produces a 1536 dimensional vector, but the ChromaDB can accept a vector of size 384, configured to reduce the dimensionality of the vector and store the vectors using each review text with an ID. And query for the best hotels near Hanover City. And based on the query, you can see like 3 documents got listed and highlighted the results of it. And ChromaDB is available as in-memory database, as a file system, and also as a server client model, like a typical database. Connect using server name and port. Client can make synchronous or asynchronous calls to ChromaDB. Retrieval augmented generation. LangChain is popular framework for RAG implementation. LangChain may switch between LLM models and versions to compare and contrast the outcome. LangChain is model agnostic. And here is a RAG pipeline. And LangChain provides several data loaders for text, PDF, and directory. And LangChain provides splitters to split documents into chunks of data, convert chunks into embeddings using OpenAI embeddings or any other model embeddings, stores embeddings in a vector database. The user query is converted into embeddings and then queries the internal vector database, enhances the user's question, and wraps it in a prompt to ask a LLM model. The LLM model processes the prompt question and generates a response. And using text loader, loaded a file. The file contains a creative text about a fictional scientific invention. Eagle humanoid is flying machine for one human being. Uses a supersonic engine to lift up and land in controlled way, similar to a bird. Engine should sound at less than 10 decibels. Allows a human to stand and operate to fly around. After landing, should also be used as a hoverboard. Design specifications are not detailed yet. And this is a fictional scientific invention character kind, and it's not anywhere in the internet. And so the idea is so that we can validate that it's not pulling the information from already trained data set. Query to explore your local knowledge vector database. Here, what is the eagle humanoid? And you can see the result as eagle humanoid is a flying machine designed for one human being, and it gives the answer for that. And thanks for watching, and that's all I have for.